Hey folks, welcome out there. It is the middle of the week. It's Mathline time. You've come to the right place. We're glad to have you with us this afternoon. I'm Ernie Roberts, and I am your host for Mathline this afternoon. Hi, that number, you know the drill, 844-686-2378. We have some great help today. We have Owie and Rhea from the Bearden High School Key Club. Let's say hello to them. They're here to answer phones. They're waving. Let's get them talking to you, all right? We want to have you guys call in, make the show rocking today. Back to school, pretty much everybody after a lot of Election Day outages yesterday and such. So we're hoping to hear from each of you and every one of you, and I'm glad you're tuned in today. 844-686-2378, that's the number. The ladies, young ladies, Owie and Rhea are from the Bearden High School Key Club. They represent their school so well. We appreciate them coming and helping us out from time to time here at Mathline. Again, we always make the plea, if your school would like to send some students over to answer phones, we'd love to have you also join us. In the meantime, while you're getting those phones warmed up, give them a call. Give me a call. We'll talk live on the air. We'll get some math done. And let's do a problem of the day while we're at it. You're going to solve for the variable. Variable x. A little algebra going on here today. This is our algebra day, so to speak, in the terms of our problem of the day work. And we're going to take an equation. It says 4 times the quantity. Parentheses always make us a little nervous, don't they? 4x minus 2, close that parenthesis right there, buddy, equals 6 times, and another parenthesis over here, we got 3x minus 5. Again, that's 4 times 4x minus 2 equaling 6 times 3x minus 5. Oh, and also it tells us that important thing. Check the solution. This is not one of those things where I'd want to look at this problem and say, let's make a guess, or 2, or 100, okay? Let's see what's going to happen with it, all right? Let's see how we're going to work through this thing systematically. A lot of things going on. And, you know, it doesn't necessarily have to come out even either. Some of you are going, what? I'm only kidding. It may come out even, whatever. I know that we've had some good responses on Facebook, and they seem to come out even. So let's hope it does tonight also for everyone else. Because if it doesn't, I may be in trouble. But let's see how we're going to work through this thing. Let's talk about distributing property, the distributive property, all right? You're going to kick that 4 into everyone in that first parenthesis. Now, don't jump over to the 6. Don't do that. The equals has stopped us, but also the parenthesis stops us, okay? So we're going to take it and quadruple. Can you say that? 4 times everything in the parenthesis. So don't forget the 2. Nobody forget that 2. Don't forget the 2. I've got 16x. I've got minus 8. Woo! Go to the other side. Go to the other side. The light side, the dark side, whatever side. Let's go to the other side. Let's distribute. I'm seeing... You're seeing, hopefully, we're going to say 6 times 3, right? We're going to get 18 with an x attached. We're also going to say 6 times that 5, which is going to give us the minus. Goes along, subtract for the symbol here, and we'll put a 30 there, all right? So everything's good, right? Signs are all correct. Numbers look good. Didn't leave anything out. All the distribution's correct. Let's move forward, all right? We'll still have to come back and check in the end, but for right now, we're going to work through this. We've got it. So subtracting our 18x, I like that. We'll line them up. It's an easy way to see how to subtract them out, all right? So you see these little guys are going. Say goodbye. Over here, we pick up a negative 2x, and the negative 8 hadn't gone anywhere. Don't put it with the 2. It's by itself. Leave it alone. Leave it alone. Put your equals down there. Now you can say goodbye to those 18s. They are gone. And now we've got negative 30 hanging out over here on the right. That looks good. Now, I've got a student out there who does a lot of simplifying on some of these things and makes things an alternative way, and I just sense that it might be out there saying, you know, Ernie, I think you ought to change all those signs and divide everything by 2. So in other words, divide by negative 2 and change all the signs. We could do that, all right? But I think the majority of you probably were just saying, I'm just going to move the minus 8 to the other side by adding 8. Let's do that, all right? But Ethan, I was referring to you. I always appreciate his insight and different ways that he looks to work out a problem. And he works them out in a good way, in a different way, but gets the same answers. And it means he worked them in a valid manner. All right, the 8s are gone, like we said they would be. Over here, I've kind of scribbled and dibbled, but I've got negative 30 and 8. It looks like a negative 22 going for us there. I like the look of this answer. Comes out even for one thing, that's for sure. So let's divide by negative 2 now. And we get x equals 11. If we'd done Ethan's way, we would have ended up with x what would it have been? Back up here, x minus 4 equals, x plus 4, excuse me, equals 15. And we'd end up with 11 also, and that's quite good. As long as you don't do what I just about did, said x minus here, got to make sure all those signs got changed if you're going to divide by that negative 2. But back to our answer. Do you like it? I like it. Oh, what if I made a mistake distributing? Let's check and see what we're supposed to have. Let's go back to our problem here. Back to square one. We're going to go back. Write it down again if you got it down at home. And let's see what the check values are going to be for both sides, okay? We're going to put an 11 everywhere we see an X. That's the game plan, all right? So we'll deal with what's going on inside here, what's going on inside there, here, there, go, whatever, and then we're going to work it out and see where we're going to go. We're not distributing it. We're not reworking the problem, my friends. We're just going to put our number that we got, which is 11. And I'm going to put a little bracket here so I can say 4 times 11. Let's see if I can put 11 in there like I'm supposed to. Minus 2. Everybody know that's 11, right? Equals, oh, bracket it. Why not? Let's see. On the other side of the coin here, that's really what we need because we don't really have another parenthesis going with that, do we? 6 times, let's bracket. 3 times 11, and we'll subtract 5. We'll end the bracket there also. So what do we got? We got some multiplication to do. Remember my dear Aunt Sally? My dear Aunt Sally says multiplication division first. Then you can add and subtract. Hence, MDAS. All right, no exponents, and really the brackets we'll worry about when we got to work inside of them anyway. So that's what we're doing, right? So we got 4 times, how about it? Let's do some mental math. 4 times 11, we got that right. 44. Lose 2. I'm seeing 22 coming out on the left side there. Well, that was quick, wasn't it? All of a sudden, that parenthesis just went melted. On the other side, we've got 6 times. Let's see what we're going to have here. My goodness, I've got 33. 3 times 11 is 33. Subtract my 5. Can get crazy here, right? Sounds like 28 to me. All right, I hope it's 28 because it looks like it could work well for us here. Let's check it out. Let's go back a minute here. Did I say 22? I sure did, didn't I? That's 42. Somebody should be calling in and telling me, Ernie, it's 42. We fixed it. We got it there. So 4 times 42, I got excited about the problem a little bit here. And 6 times 28. Do we get the same things? I can already tell you this side is 168. This side I may want to hit the calculator and make sure it works. Let's test 28. And we're going to multiply it times 6. And I'm getting 168 also. So we have a check. We have an x equals. Life is good. And that's your problem of the day. All right, so now, folks, what are we going to do here? This is called Mathline. It's a call-in show. We've got a number. It keeps flashing across the screen down there. Going to tell you, I think most of you hear me day in and day out. We want to hear from you. 844-686-2378. Give us a call. We will work some math problems out here live on the air and have a good time doing it, hopefully. And you've got your questions. You've got your problems. You're back in school today. Everybody's back in school today, right? Yeah. Hey, it's a good day, right, when you're back in school. But so give us a call. We got Rhea and Owie out there working away, and we want them to work for us, all right? Do a little math on the phones? No, give some answers. They'll take care of you, get you in here to me, and we will have a good time on the show. In the meantime, you know, we've always got some problems waiting for you, but we like to hear from you, okay? So again, use that number, 844-686-2378, all right? And let's see a little problem here that we got going on while we wait for some calls here. Crazy looking figure here. It looks geometry, doesn't it? And hopefully that y'all are beginning to see. Let's see, can we scoot that up a little bit? We might be able to. That help a little bit? My director says we want to see all the A and the B down there. And we'll be working out some things here in just a second. Some information on this figure. Now, there are a bunch of angles. Whew, a lot of them. I see 8. And I see 1. I guess I could put a 9 there if we wanted to, or I put and 1 out here. Oh my goodness, there's just a lot of angles that we didn't even mark. But what we're going to look at here, what if I were to tell you that this angle 7 were worth what? 60? And over here we have this angle, it could be worth 40 degrees. And again, keep in mind these figures don't really get drawn very well to scale, but they're nice and fun to play with anyway. And we'll still manage to get 180 degrees in each triangle, hopefully, in the situation here. Now, I just gave it away, didn't I? 180 degrees in a triangle. Everybody knew that, right? Everybody knew that. Even my calculator knows that probably. Now, what are we going to do about these problems? there's some information waiting for us up here. Let's go back to the information before we start running too much. You know, we tend to gravitate toward numbers like 60 and 40 so quickly. But what else is up there? Information's giving us some hints to this problem. I run in some parallels. I've got a perpendicular. So okay, let's talk about what is parallels. Parallels mean they do not intersect. They run basically coplanar and they never cross each other. And they also set up some interesting angles when a transversal pops into the picture. So we'll be thinking about that. Perpendicular, that tells me we're going to find a right angle. So first of all, let's work at that right angle concept, because that will help us crack this problem also. If we have a right angle at, where was it? DB, so there's your DB, okay? There's your AB, so there's the right angle. So 4 and 7, all right, 4 and 7. Let's kind of go back here just a little bit, sidetrack just a tad. We'll put these angles down as we figure out where we're going. And by the way, the M stands for measures. For measures, so measure angle 1, measure angle 2, measure angle 3. We know angle 2, don't we? We'll put a big 40 right there. That's degrees, by the way. These are nice numbers, so we don't have to really do too much calculator work. We can mental math this thing through. We got angle 3 equaling. We'll go ahead and put angle 4 down here. And don't know what they are yet either, do we? All right, let's cut over here to the other side of the picture. I'm seeing measure of angle 5, hopefully going to be equal something. Of course it will. Measure 6, there we go. Measure 7, which we already have a little clue about. So we got a 60 there. And what's our last one? I guess measure 8. There we go. All right, so pretty good. You say, of course, Ernie, we already know what the first two were, so there you have it. So hopefully everybody's gotten this thing written down, drawn this thing at home now, if you're working with me along. Hope you are. Let's talk about what happens if this becomes a right angle. I'm going to make a big right angle here, because this helps me find the measure of angle 4. You know why it does? Because I know these two have to add up to 90 degrees. So I've used up 60 right here, and if I'm going to make a nice 90 degree with 4 and 7 coming together, that's going to give me a 30 degrees right there. Nice angle, 30 degrees, all right? So here we go. Angle 1? No, it's angle 4, isn't it? We'll have to figure out what angle 1 is in just a minute. I don't know. It may be. I don't think it's going to be 30. We'll find out. We'll find out. It's always interesting in this situation. What is it going to be? Kicking along here. Parallels. What's important about parallels? Well, again, it tells me some angles may match up along the way here. Maybe I could find angle 1, but here's my parallels. Let's mark them with parallel symbols. And while we're doing all this thing, hey, folks, give us some calls, all right? We've got the two ladies from Bearden, Owie and Rhea, out there. Let's make it worth their time coming in from the Bearden High Key Club for some community service today. We want to be able to help you guys out, so give us some calls, all right? And let's see what's going on. I've got a 40 down here in this corner. You know what? If this is a right angle here, and these are running parallel, you know, this should be a right angle also, because in the big scheme, these guys have to add up to 180 all the way across through here. They're what we call same side. So we got a right angle going here. There's another one. So that allows us to get angle 3 out of our worries here, right? It looks like we got a 40 here, so we're going to put a 50 right there. And there we go. We're starting to work. Starting to get somewhere. Now, thinking, and thinking, all right? Where do we go from here? We got a couple options. You want to go 5? Everybody want to go to angle 5? What do we got? We've got 50, we've got 30, which gives us 80. And that leaves me with, how many? 180. See what I've got? I got a little triangle going here. So my angle 5 looks like it's 100. So I'm going to pop that 100 degrees right over there. That was good. And, oh, why not? This angle 6 looks like it's supposed to be worth, what, 80? Because, why? Because it makes a straight angle, right? Linear pair, add up to 180 degrees. Life is good. So we put an 80 right in there. Oh, my goodness, we are almost home. We are definitely home free. Because look what we got. 40, 80 makes 120. So what's going on for angle 1 up here? I've got a 60. And I guess what's left over here, we say, Ernie, you don't have an angle. Oh, yes, we do. We got an angle right there of 80, linear pair or vertical angles working. And I believe angle 8 is going to come out to be 40. Put a 40 right there. And if you'll notice something, my friends, if I put my 60 back up here, I have 180 degrees in all those triangles. 180 degree here, 180 degree there. Oh, we can even think big. How about it? CAB, I got 30, 60, and 90. That makes 180. Think about it, DBA, 40, 50, 90. So in either case, they all add out, they all work out great. And one more little check here. Remember we talked a little about the parallels? Alternate interior angles, 1 and 7. They both are worth 70. No, they're not worth 70. They're worth 60, aren't they? And how about it? Angle 2 and angle 8, also alternate interior angles, and they're both worth 40. So that's another option with the parallel lines that could help us out. So cool problem there. Lots of ways to get through the answers. ACT written all over it. Yeah. And with those nice numbers, you can do mental math. So, I understand I have a caller waiting for me, and welcome to the show this afternoon. And who am I talking with?
Lily.
Lily, how are you doing today?
Good. How are you?
I'm doing fine, doing fine. Where are you calling from?
Knox County.
Knox County. Great to hear from you this afternoon. What kind of problem you got for me?
An isosceles right triangle has a hypotenuse of 12. Find the length of both legs in the same triangle. Also find the area and perimeter.
Oh my goodness, you got all sorts of stuff going on in this one, don't you? All right, well, let's see what we're going to do. I'm going to play it out here. So let's go back again. You said an isosceles right triangle, correct?
Yes.
That tells us a lot. Gives us a lot to go on. And let's see, as we draw it out here, we'll create it. And we hopefully have, by the way, why did I say it gives us a lot to go on? This, folks, isosceles right, first of all, it tells me we got a right angle. It also tells me we have two congruent sides there. So that works really nice, very nicely for us. Now, here we go. It is time to put in the hypotenuse. And Lily, I think you said 12, right?
Yes.
All right. And we're just going to use 12. I don't think it said inches or feet. You didn't give me any units, as I recall. So we can put whatever units we have on there. So, but the question is, what are these legs? One good thing is I know they are the same. All right. So now, Lily, I'm going to ask you, do you remember a good old friend called the Pythagorean Theorem?
Yes.
All right. And that's what? That a squared plus b squared equals what?
C squared.
C squared. Yeah, you got it. You remember. Now, since these are the same, I'm just going to call them both a. How about that?
Okay.
Will that work? So what we're going to do, we're going to play this a squared plus not b squared. We'll just go ahead and say a squared. Equals to, how about it, put 12 and square it there. So far, so good. See what I'm doing? Good old Pythagoras will be proud of you today, Lily. You remembered his theorem, a squared plus b squared equals c squared. And I'm going to go with the fact, I bet you know 12 times 12, but just in case, I'm going to say it's what, 144?
Yes.
Good. And by the way, I've got an a squared and a squared. What are we going to get when we add 1 and 1? I know you can answer that. Yeah. And I'm going to have 2 what then? I'm going to have 2a squared. I notice a little hesitation on you there. And it's also very important to realize that a lot of our geometry students and algebra students, when they see a problem like this, they want to add those exponents too. They're just an a squared, get another one. I got 2a squared. So that's where we are. Are you good so far?
Yes.
Follow what I did. All right, now, I want a by itself. And what is this 2 doing? 2 is what? Multiplied times a squared, correct?
Yes.
So we're going to get rid of it. And we're going to take and divide both sides. Oh, we're going to have to lose my bottom third, it looks like down there. We're going to divide by the 2, since that's how we unhook multiplication. Now, can you do a quick division for me here and see a squared is equal to how much over here? What's 144 divided by 2?
72.
I like 72. That was easy, wasn't it?
Yes.
Now, here's where we get to the point of interesting problem. I'm going to rewrite it up there so we got room. Sometimes your book will say take it to the nearest tenth or nearest hundredth. This one is not a perfect square, so we're not going to get an exact decimal form, okay? But I bet your teacher has taught you how to make these things work in terms of rationalizing, right? In other words, simplifying the square root. Because what we've got here,
Yeah.
when we hit that square root on both sides, we got a equals the square root of 72. Which is fine if you want to, if at this point, if it's asking for decimals, but I didn't hear you ask for decimals. I think we're looking for actual roots, aren't we? I think we're playing that game here, yes. So we want to look for the exact value. So here's the deal. My friends out there who are watching, you need a perfect square that's going to divide into 72. There are quite a few, actually. 4 will do it. 9 will do it. Oh my goodness, if you multiply 4 times 9, 36. 36 will divide into 72. So let's go with 36 times 2. You see where I'm going? Does this bring back memories? I like that. So tell me, what's the square root of 36 that we've got hanging out in there?
6.
Yep. The 6 comes out. The square root of 2 stays behind. So your first question was what? What are the lengths of the legs, right? Basically?
Yes.
So there you have them. Right there you are. So let's put it right in there. 6 times square root of 2. Over here, this little guy is 6 square roots of 2. And we're going to look for perimeter. Perimeter means what? What does perimeter mean to do?
Add all the sides.
Okay, yeah, we got 3 sides, so we're going to add the 3 sides together. Now, Lily, I bet you're getting nervous. And this is probably why you called. Now that you see where this is, you've got 12 plus 6 square roots of 2 and 6 square roots of 2. And we're going to keep the 12, and we're going to join these two together because they are like radicals. And that's your final perimeter right there. Is it? No, it's going to be what? Let's try that again. Boy, how about it? We'll do 12 plus 12 roots of 2. Is that better?
Yeah.
Do you see where I got that? I take 6 and 6 and I get 12. I was going to write 12 plus 6 roots of 2 and then 6 roots of 2, and my train of thought just goes away sometimes. So, but there's your final perimeter right there, whatever units we were using. So that part wasn't so bad, was it? By the way, don't add 12 and 12 together. We don't want to do that because this has no square root of 2 attached. This one does. Let's go for the area. Area equals, it's a triangle. Oh my goodness. Is that 1/2 base height formula, right?
Yeah.
And let's see what happens. I'm about to run out of room, so we got to make something happen quick, don't we? Got a 1/2. Oh, there's the base. Up there's the height. So these two numbers right there are what we need to use, isn't it?
Yeah.
So 6 times the square root of 2 and another 6 times the square root of 2. Woo! I'm almost off the screen here. Let's see what we're going to get. It's going to be 1/2 of, let's put those 6's together, multiply them out. 6 times 6 gives you how much? We've been there before, haven't we? 36, right? Oh, here's one. Square root of 2 times the square root of 2. I'm thinking, you thinking, what are we going to get? Wow. Square root of 4? And what's the square root of 4 going to give us?
2.
And there we have, oh, no more roots. Roots gone. You know what I'm thinking? We can just go ahead and say goodbye to those 2's. Because it's like 2 over 1, isn't it? And we got a nice whole number there. Nice, actually, integer there. Positive integer, of course. It has to be. It's because it's area. And checking our arithmetic, I didn't say yours because we're both kind of in on this together. We did do it right, yeah. So 1/2, the formula, substitute, do the multiplications there, multiplications here, take the radicals together, and that's where we go. It's 36. And so there's your area, there's a side, there's your perimeter. My goodness. And what's cool about this, Lily? We got all that from one number. We started with 12 and worked backwards. Is that pretty good?
Yes.
All
Thank
right.
you.
Hey, thank you for calling this afternoon, all right? Now, folks, Lily's done it. Let's get some other folks on that. That number, 844-686-2371. Oh, they tell me we've got about 1 minute left. This must have been a pretty hefty problem set there. So I will tell you this. Let's go ahead and take a look at Facebook while we're at it then, all right? Like us, love us, share us. We want all those good things to happen, especially where you can see our problem of the day posted in advance. And as I said, some of you chime in on Facebook with us and all. We want you to like us, love us, and especially share us because that gets us out there with all your friends and such. We have www.facebook.com and a /Mathline online. That's where we want you to go. Second part of this, going to YouTube, where you can see such great things like our Halloween show that we had last Thursday and other of our shows that we do on the Friday specialized segments or the holiday specialized segments. And you subscribe to that by going www.youtube.com /just Mathline. Don't put an online there. You may not find us there. But that's YouTube. So Facebook, YouTube, and of course live on the air, that's where we'd like to see you. We'll be back again tomorrow at the same time, and we will look forward to seeing you then.